Thank you very much. Nice to see everybody again. My name is Matt Kixmoeller. I head up product management, product marketing for Pure Storage. And I thought today most of you had probably heard some part of our pitch in the past, so it'd be more useful to just have a little more fun and talk a little bit about what we've seen over the last few years. We at Pure Storage have been shipping enterprise flash for about 3 years now, through various early adopter customers on through to GA at the beginning of the year. And we've seen a lot of change in the market over the last few years. And so I thought I'd ruin my complete sense of surprise today by giving you the answers up front, and then we'll just dive into each of these as we go along over the next couple of minutes. So the first thing is there's a lot of discussion around what's the right model for flash. And what I'm seeing more broadly is that flash is really just disrupting every segment. So we like our approach. A lot of the other vendors you'll hear from today like their approach. And in a lot of ways, everybody's pretty much right. You know, this is a transition that's happening at all parts of in all corners of the storage industry right now. The second thing is when we look about, a lot of people will ask us, all right, what's the key thing that makes Pure Storage, or what's the key thing that allows flash to really go big? And in our minds, there's a lot of core technologies, but if you have to boil it down, the most kind of transformational enabling technology for us is all around data reduction. And it's how flash can really break through cost-wise to become a mainstream technology. And it turns out that a lot of people will say, dedupe is just kind of commonplace at this point. There's just massive differences in how people actually do data reduction and what it enables. So we'll get into that a little bit. The third one I think might be a little bit of a contentious point in this conference, but from what we've seen, Tyrion is largely a compromise. And that doesn't mean it's bad. There's parts of the market where that compromise is worth it, and there's different optimizations. But we go after a part of the market where performance really can't be compromised. And so we'll talk about that and why we believe that disk, for a big tier of the applications, just has no place anymore. And that brings it to the point where we're seeing that flash is suitable for a big chunk of applications. A lot of the first generation of flash was all about really finding that mission critical, high-end, super IOPS focused database where you could afford flash and where it would turn things around. But the flip has happened now where for most enterprise applications, flash is quite a viable platform. And then finally, in our minds, way too much of the discussion around flash has been performance over the last 3 to 5 years. And what we've seen in our early adopter customers is that at the end of the day, the thing that becomes most transformational for them is just not having to wrestle with the complexity of making traditional disk storage actually perform. And 9 times out of 10, when we go into a customer that's done a POC, that's bought Pure Storage, I'll ask them, what made you do this? And the number one thing that comes out of their mouth is all around simplicity. So we'll dive into each of these as we go along. So just a quick side to quickly introduce Pure Storage. We're basically a 3-year-old flash company at this point, made up of a group of folks that have come from all parts of the storage industry around the Bay Area. We've raised close to $100 million in total investment. And for us, that was really a necessity in terms of building a global storage organization. If you look at a lot of what we've done over the first couple years of our existence, it was build a great product, get it out there in early adopter customers' hands. But what we're really focusing on this year and next year is scaling that company to be a global storage organization. And when people buy storage, they don't just look at the technology, they look at the entire company that's behind bringing it to market, supporting it, and offering that mission critical experience. And so Pure Storage is as committed to the technology side as the overall experience. A little bit about our product just for some baseline. Fundamentally, we build an all-flash storage array. And our key goal is to build that storage array in a form factor that allows it to be easily adopted by traditional enterprises. One of the big challenges of the first generation of flash storage was that it kind of didn't fit in the existing compute model. So we went out there and said, look, we want to build something that looks and smells and acts a whole heck of a lot like a traditional storage array, but is just dramatically faster. And part of that is hitting the price profile of what people pay for storage today. I have one of the easiest jobs in the world. Convincing people to buy flash is not hard. People want flash. The problem is, for the most part, up until now, they just haven't been able to afford it. And so the key goal of our platform is driving the cost down of flash to a point where normal use cases can take advantage of it. And so that means using a combination of MLC, consumer-grade flash, inline data reduction technologies, but not compromising on the enterprise resiliency, scale, and feature set that's necessary to really make it into traditional applications. All right, so let's get back to some of those observations. So I'll often get asked by people, look, as Steven said, what are there, 60 flash companies out there? How does this market really segment it? Because there's a lot of confusion, and it's not kind of all one space we're all going after. So if you look at storage, it's always been defined a little bit by kind of tier 1 and tier 2 disk. Tier 1 was the fast, expensive 15K disk. Tier 2 was the more capacity-centric SATA disks out there, where one was a little faster, one was a little more expensive. And so you had these optimizations for kind of the performance tier and the capacity tier. Flash storage in the enterprise is not new. It's been around for 15 odd years. Think people like TMS, Fusion IO, et cetera, who were early movers there. And that first generation of flash is the small dot in the top right there. Fundamentally, very, very high performance and very high cost. And so it found a set of use cases I talked about earlier where a few of the most critical database applications could really afford it to be used. And so, by and large, most of the sales of flash in that early generation were to high-end DBAs. Come along with caching, and caching via flash by taking your old existing disk array, adding a little bit of flash to it is transforming that existing model, where now you can get a bit more performance out of the existing disk environment. But it's not fundamentally changing the game for the overall performance as possible. And at this point, I think I'd say if you're looking to buy a storage array, you should certainly be looking for one that at least has a little bit of flash in it. And you should probably be looking for one that was really designed with flash at the heart, whether that be all flash or really fundamentally taking advantage of that flash cache, not as kind of an adjunct to an existing disk architecture. So what we think, though, the real potential transformation here, though, is if you can drive down the cost of flash to the point where it's in line with the cost of that traditional performance disk, what we used to know as Tier 1 disk really gets kind of squeezed in the middle. And what we see is a future where there's absolutely still different tiers of storage. We're not out there saying flash is going to take over the entire world. But largely what we believe is you'll see a future where you've got any kind of performance-centric application running on an all-flash array that's been highly cost optimized to make that possible. And things that are fundamentally more capacity-centric, SMB-type use cases, small enterprises, probably picking tiering arrays where the flash really substantially helps with that for it. And you'll hear, both these are big markets, both these are great markets, and you'll hear from people today that are really pushing the transformation in all parts of this diagram. All right, so let's talk a little bit about dedupe. Dedupe is, I think in one way, one of the more misunderstood technologies in the flash space. And there's been a big focus on data reduction in terms of cost. It's obviously important from a cost perspective, drives down the effective cost of flash. We make a big push around that with our story and our technology. But the other thing that's important to understand about data reduction is write avoidance. And so as you push forward to more and more generations of consumer-grade flash, where that endurance gets lower and lower every generation as the lithography goes down, it's just as important from a write avoidance technology. And so dedupe is key for both, and our belief is if you look forward to generations of flash products based on TLC flash, et cetera, you just can't get there without functional inline data reduction. But in our minds, the devil here is really in the details. And we've seen a lot of folks look towards trying to add on dedupe. I think a whole generation of disk vendors over the last 5 years has realized that even though dedupe was doable in the backup space, turns out to be quite hard to add to primary disk arrays and maintain performance. The metadata required, if you didn't fundamentally build your product to do it, is just very hard to manage. And so as you look at kind of products where you'll see increasingly people say, yeah, we do dedupe, sure, we've got that, check. You really have to look at how it works. And so you have to look at questions like inline versus post-process. Post-process dedupe is great if you don't care about lifespan. Because for post-process dedupe, you have to actually commit all the data to flash, reread it, dedupe it, and put it back again, which doesn't do anything to avoid writes. It actually increases them. Performance impact is key. You have to look at the performance impact. Many of our competitors will say, yes, we have dedupe, but you probably should turn it off if you care about performance. And so in our product, as an example, dedupe is just fundamental to how the product works. Can't turn it off, and so all the performance we talk about is always with that enabled. The reduction in block size is important. Most people out there will do data reduction on a 4K block size. We actually do it at a 512 byte chunk size, which takes more metadata and more processing, but has a higher return in terms of the data reduction. It also has some nice benefits in auto alignment with everything above, which tends to be a multiple of that geometry. And then finally, in our array, we do both dedupe and compression. And you'll see a whole variety of people where some will do dedupe, some will do compression, some will dedupe on the flash tier, but not on the disk tier, et cetera. And so if you look across our use cases, all of our arrays call home every night. We get a sense for how workloads are doing, what kind of data reduction people are getting. And the value is about half and half. In things that look and smell like VMs and VDI, there's a high benefit of dedupe, but they also compress. And things that look more like databases, compression is the dominant benefit, but you get a little bit of benefit from dedupe. And so if you're looking for an array that really can host a wide variety of workloads, it's important to do both of those well. All right, Tyrion is a compromise. I'm sure this one will be an interesting discussion point as the day goes by. When I've talked to customers about Tyrion, you almost never have people say, wow, I really envision the perfect product to be a whole bunch of disk with a little bit of flash. Most people like the idea of all flash, just intuitively. There's just no surprise around performance. But the question has been cost. And so why does all flash matter? When we look at basically existing disk array technologies, what you see here is a histogram of performance, where the top three charts here are traditional disk arrays or disk arrays with flash caches, or even something like a PCIe card in front of a disk array. And you see a bimodal distribution of I/O, where some of the I/O comes at the fast flash or DRAM zone, and some of it comes at the disk zone. And fundamentally, how much I/O is in each of these buckets will come down to how cacheable your application is, and whether the same blocks are being hit all the time or not. And the hard thing that I think people don't often understand is that I/Os aren't independent. And so it turns out that above your app or your storage array, usually there's some sort of a application that's driving transactions, that's having multiple I/Os come down to the storage tier. And if even one of those I/Os in a transaction falls onto the disk side, that whole transaction is waiting for disk. And so our belief is that the number one thing you can do to get consistent performance is to roll up that long tier of slow I/Os all to the flash zone, which can really only be done with an all-flash product. And of course, look, there's some workloads where that compromise doesn't matter. You can compromise by mixing with disk and probably get products under the dollar per gig range, where you'll never be able to get with flash. And so it just depends on what's important in your environment. Is consistent performance important, or is ultimately optimizing to the lowest cost per gig important? And there'll be markets for both. Flash for most applications. So when we started in the flash space, we had basically all flash being sold to DBAs. If you look at the early flash pioneers, their basic strategy was actually to avoid the storage team, go directly to the DBA, and sell flash as essentially bottled rocket fuel for a mission critical database. What we've seen is that's dramatically changed at this point. If you look at our customer base, you can see some of the logos there. We sell into a wide variety of use cases, from some of the highest end database applications in top 5 investment banks, top web companies, on down to smaller customers out there. And basically, the key transition has happened where flash is becoming an everyday technology for general purpose storage. And the needs change at that point. When you go and sell as general purpose storage device, it's no longer enough to be a small device that can just be scaled for a single application. HA is required, and the broad enterprise feature set is required. All right, and Stephen's pointing me at the clock, so I'll speed up to finish here. And then the final thing, and this is one that I'd say was quite anti-intuitive to me when we started Pure, was that at the end of the day, simplicity is very powerful. We like to pick on some of our existing disk vendors from time to time. What you see on the left here is actually just a reference architecture from a major disk vendor about how to accomplish VDI reasonably on their storage device. This happens to be a hybrid array with some SSDs and SAS and whatnot. And you look at that recipe and you say, wow, I'd love to spend just hours and hours trying to perfectly lay out my disk array in that manner to get what might be reasonable performance. And heaven forbid if anything changes or I need to make modifications, et cetera. We've gone in and tried to deliver a product that essentially requires no tuning. The entire concept of things you do on the back end of a storage array, things like setting and managing RAID, worrying about block alignment, rebuilding from failures, managing all these different tiers, just completely melt away. And it's easy to kind of say, yeah, we're simple, but it's just hard to underestimate what a difficult compare it is with traditional storage, and how frustrated existing admins are with what they have to do to not only manage those arrays, but actually get reasonable performance out of it. And so when an average customer goes in and compares the experience of ordering a big enterprise array that comes to their loading dock, and if they literally take it out of the box, they avoid its warranty because they have to get the array company to come and set it up and spending a week tuning it, with the experience of a Pure Storage install where it arrives, you got it in the rack. I think our record install is out of the box, fully performance storage in under 13 minutes. We try to beat that with every install. But it's just a dramatically different experience. So with that, I'll stop now, and we will have questions, I guess, as part of the panel. Thank you very much.